My greetings to the conference participants. My name is Ludmila. I want to present you the results of a study by employees of the Center for Problems of Marine Geology, Geoecology and Sedimentary Ore Formation, the National Academy of Sciences of Ukraine. Modern scientific challenges require a cross-sectoral approach in all scientific fields. That's why our group resolves some ecological and economic problems by geological methods. It is an example of geoecosystems approach. Such examples prove the close links between geocomponents. For the beginning, let me describe the preconditions of the study. The object of our research is modern bottom sediments. Modern alluvium is a complex multi-component system that includes both natural and man-made material. The bottom sediments provide important data about the anthropogenic impact on the geoecosystems of river basins. It is a very informative source. The main task of our research was to evaluate anthropogenic load in bottom sediments of the Ingles River and its tributaries. In this process, we established the presence of commercial products of mining and processing enterprises in the sediments. It includes crushed granite, metallurgical slag, ores and concentrates, coal, and other products. You can see the examples of findings in bottom sediments of the Ingles River photos made through binocular microscope. Amount of this material so great that it will be advisable to use for economic purposes. It is enough to develop and implement the appropriate technology. That's why we decide to evaluate potential for industrial exploitation of modern river sediments in the Kryvyi Rih industrial region. To achieve these goals, such methods were used: the analysis of granulometric composition, the determination of specific density, the evaluation of magnetic component, the qualitative and quantitative mineralogical analysis, the separation in the vortex air mineral flow. The Ingles River system is diverse. In upstream, it is simple steep river, but at the territory of the crevasse, the terraces of the river valley are buried under heaps of poor rocks and the sludge storage and other industrial buildings. The samples for our testing were taken from different parts of the Ingles River stream. According to the size of samples, it's grouped in three zones. Zone first, relatively low industrial load. Zone second, extremely industrial load. Zone third, post-industrial load. Such a division is justified because receipt of additional sedimentary material with industrial origin occurs within the Kryvyi Rih city. It is approved by results of granulometric analysis, specific density, and magnetometry. Psephites and pellets have almost equal parts in bottom sediments from zone first and zone third. In zone second, pellets have little part, only 3.5%, but psephites and psamids fraction are increased in twice. It means that a great amount of additional roof particles are added to the bottom sediments in this part of river system. The similar regularity is approved by results of measuring of specific density of bottom sediments. The indexes of density are increased and have wide range in zone second. The part of magnetic component in zone first and zone 3 is less than 1/4%, but in samples from zone second it is almost 60. So large part of magnetic components is in samples from zone second confirms the presence of mining and processing and metallurgical waste in the bottom sediments of the Ingles River on territory of Kryvyi Rih. The mineralogical analysis was performed to further confirmation of this statement. Due to it, the percentage of natural and man-made elements with magnetic properties was evaluated. The technology for separation of river alluvium in the vortex air mineral flow is based on the physical properties of the particles. The difference in magneticity of the alluvial components provides opportunities for dividing sediments on pods due to influence of the magnetic fields of varying strengths. More detailed description you can find in our full paper. I just say that in the end of the technological process we receive the concentrate that corresponds to the composition of iron ore concentrate of medium quality produced by mining and processing plants. The main benefit of the proposed technology is vastly free enrichment of iron ore. There are no need for any additional reagents and toxic or hazardous agents. Tailing from the separation in the vortex air mineral flow is quartz sand and could be used in building industry. Summing up, technogenic components and natural iron minerals are mixed in the river system. Due to it, the bottom sediments become the secondary natural man-made deposits of heavy iron minerals. The processing of bottom sediments is only one of the ways how the technology can be applied. It is suitable for recycling of tailings, slags, and heaps. Presented results are only the introduction to great research. We show only possibility of such enrichment. Next steps must be, for example, detailed economical analysis, improving the methodology for sampling, projecting and industrial separator, and etc. Thank you for attention.